Dr. Dinesh Kumar, Head of the Department of Mechanical Engineering, faculty members, and my dear participants. A very good morning to one and all. I congratulate the Department of Mechanical Engineering for organizing such an FDP on important topic of this contemporary research and manufacturing engineering. I hope this FDP will help all the participants to enhance your knowledge on the particular topic, because the FDPs are regularly organized by various institutions to equip the faculty members and researchers on the current trend. In this context, Karpavanagar College of Engineering and Technologies, the Mechanical Engineering Department has organized this wonderful program. I request all the participants to make use of this opportunity for the 1 week, and definitely all the speakers, they are all from reputed institutions, will deliver and provide enough input for the FDP. I once again thank all the participants for attending this program. I congratulate the department for organizing such a program.
Very good morning to all. Respected Principal of the College, Dr. Kashan sir, beloved HOD Dr. Dinesh Kumar, the coordinator of this program, Dr. Ilayarasan, and dear faculty members. I am extremely grateful to the Karpavanagar College of Engineering for inviting me to inaugurate this faculty development program on contemporary research in manufacturing process. It's a nice day that we are assembled here, and now you know that India is driving towards Atmanirbhar Bharat. That means indigenization and self-reliant India. So for indigenization and self-reliant India, what we need is that we have to have more and more industrial and manufacturing process to be developed, and the product manufacturing has to be done in India so that we will be self-reliant. And in this context and the current scenario, definitely this faculty development program is one of the priority area in the engineering and science and engineering sectors, or maybe in the industrial sectors. So we organized many faculty development programs, workshops, and conferences. But what I request is that even though we get a lot of information, there are a lot of speakers, I request the faculty members even inform the matters what you learned from this faculty development program next to the students, because you are the interfacing between the experts and the students through this faculty development program. Now you know that it is not that every time the engineering students has to be a job hunter, but they have to become a job creator also. That means they have to become an entrepreneurs and so on. So to equip on both sides, suppose they are job seekers or job providers or job creators, they require the knowledge of this manufacturing industries to a larger extent. Because unless they know what are the various newer manufacturing technologies coming in, where they can develop their own skills, both if they are looking for job or they are going to create their own industries, then definitely these manufacturing sectors and advanced manufacturing process is very much important. And it is necessary that the faculty members has to disseminate this knowledge to the students, and also maybe in futures, apart from the faculty development, you can have the workshops and symposium, because now everybody, because of this lockdown, is there at home, and maybe you can even create, because now there is no limitation of participants. Maybe the students of mechanical engineering, manufacturing engineering can come together. You can even have the talks by experts directly to the students also, where the faculty as well as the students will get benefited. That also is would be nice. Maybe 1-day program, 2-day programs. I thought maybe what you can do is that maybe you have your own students in the leading industries or maybe in R&D institutions and so on. You can directly contact them and give talks so that they will also, students also will get motivated during this lockdown period. Even though our GDP and everything is coming down, but always there is up and down in the economy, and we will hope for the best. I think maybe after a couple of years, definitely the things will into a good shape, and especially the manufacturing intensive sectors will be having a lot of scope for the growth. Coming to specifically for manufacturing, you know that manufacturing sectors, as a broad sense, it includes metal casting, or in general casting, forging, secondary processing, just like rolling. Then you have the welding or the joining process. Then you have the large different types of machining process and so on, which finally ends up in making a component. And more than that, the area of materials is also plays a major role. So that means materials and manufacturing goes hand in hand to end up with a very good product, quality product, so which can be finally made or integrated to a system to make the whole equipment or the machine or the system what you are going to aim for. And since I am working in the area of materials, especially on composite materials, lightweight metallic materials, both these composite materials and lightweight metallic materials have a lot of scope in the area of both research as well as in the industrial sectors. Because anything before going to the industries needs extensive research, validation, the prototype development and validation both at the lab scale as well as industrial scale and in the field trial. I think this is the area where as faculties can play a major role by taking industrial consultancy project on developing lead products. One is identifying the newer and newer materials which can be integrated through the manufacturing systems with better properties. Because one of the main criteria for utilization of lightweight materials in manufacturing of engineering component is because of the reduction in weight, especially for transport sector. Transport sector means it covers both automotive, aerospace, and avionic systems. Because once we keep on reducing the weight of the engineering components, definitely what we can do is that we can increase the payload capacity. That means the passenger capacity, or one, if you take a rocket, means it is the payload of the satellite, the launch, the satellite capacity. That means weight of the satellite or the prop satellites to be launched. So lightweight materials, especially lightweight metallic materials and lightweight composites, play a critical role in this. But the main problems in this area are having a proper manufacturing process, which will end up with providing you a material or the component with the required properties. So this integration between materials and manufacturing is very critical in having a very good quality product. So if you see that a lot of advanced materials or manufacturing processes coming up, the very recent is on additive manufacturing. Maybe the additive manufacturing of polymers is existing larger in the industries, but if you take metal additive manufacturing, is one of the newer process which is coming up. And here again, there are a lot of difficulties in bringing up products, because one of the major limitations is that we can have a near net shape products, but once we go for a huge number of products, then the economy of this metal additive manufacturing will come down. So for that, suppose you have minimum number of products, because another area where we can have, especially the space sector, defense sector, they develop only minimum number of systems. So they want only limited number of components, and there definitely these type of additive manufacturing can play a major role. Apart from that, even in the area of biomedical sectors, for example, if you want to create implants which is designed specifically catering to the patient specific implant design and or manufacturing of the implants, definitely this additive manufacturing can play a major role. But one of the difficult thing at present is the cost of the metal additive manufacturing equipment runs into crores, maybe 3 to 4 crores for even a simple equipment. So that doing R&D in those metal additive manufacturing is also difficult. And another area is raw materials for this metal additive manufacturing is another areas of difficulty, because in India we don't have good quality metal powders which can reach to the standards of metal additive manufacturing. Because we have metal manufacture, even in Madurai, we have the metal powder company and various industries, but they mainly focus on the areas of what you call the powder, traditional or the conventional powder metallurgy. So looking beyond the traditional conventional metallurgy and creating quality powders, quality composite powders, specifically aimed for high value product is another areas of research which you can look for. And even in the area of traditional metal casting, the sand casting, gravity casting and die castings are well known and a lot of industries are there. But even newer processes like low pressure castings or even the advanced centrifugal casting to create functionally graded materials and components are to the areas of skews casting, where you can make near net shaped components or lightweight components with better properties, also one of the other areas. And the areas, another areas of manufacturing is the functionally graded materials and functionally graded components. So what is functionally graded components? So any components which have location specific properties within a particular region. So that means that's an inverse design procedure. What we have to do is that we have to take the common requirement, analyze the properties, then come and manufacture by integrating different materials, different processes, and you can make components out of that. So this FGM and FGM manufacturing is another broad area of research if somebody is interested to take, and a lot of scope is there. And these are all mainly tackling specific needs of the industries. I think I'm not going through the details of the different manufacturing techniques, because you have already many people giving these talks on different sectors of manufacturing, starting from, I think, we have on friction welding processes, wire cutting, then CNC, wire electric discharge machining, and acoustic emission by Dr. Seaman, surface modification of lightweight materials. Another is the surface modification is another broader areas, because once you manufacture the components by traditional manufacturing process to put into the use, especially to create high wear resistance. For example, if you take an engine components, normally they give either a ceramic coatings or a hard metal coating based on nickel or a nickel based composite. The Nicasol is one of the high temperature resistance coatings which is given for automobile engines, which you disperse a lot of fine particles and you can make harder composites. And another area is on NDT, that is NDT techniques for validating the manufacturing products, whether the quality you are able to maintain and so on. So you can see a host of manufacturing processes are there, a lot of lectures are there. I hope this event will be very much useful for the all the faculties, those who are attending this program. And I wish that this 1 week program will be very much benefit to the all the faculties, and the faculties will be in turn disseminating their knowledge to the students in future. I once again thank the organizers of this MDP program for giving the opportunity to deliver this inaugural address. I especially thank Dr. Ilayasan for inviting me. Thank you all. Thanks a lot, and all the best for the program. So I declare that this FDP program is inaugurated, and thank you very much. Thank you, sir.